Guys, these modules are embedded with maximum power point tracking, which stands for MPPT. So right now, these are the modules. See, I'm just giving you a tip, and like I was saying, and let's go back to the things that you're gonna be looking at here. Because first thing you want to do, you have to configure your batteries or what battery bank you're gonna be utilizing and all that kind of stuff. I'm gonna be trying to do this video quick for you guys. Well, these are 48-volt system. So battery connections and the recommended batteries, they're gonna be AGM, sea lead acid, fluoride lead acid works on these ones, as lithium as well, the latest technology. So I just want to tell you that you don't be hesitant to buy any of these devices. But you have to know, the maximum amperage, the battery capacity, the wire size, and like the gauge, the AWG, the millimeters, and you know, you have to know the turking of these terminals. Are you gonna tighten up your stuff? The input of the AC wire output. So these are all a lot of features that you're gonna be dealing with here, because these are international versions. The wire is gonna be different, which is it has different coloration. You have to understand the typical amperage on these devices to know how much panels you're gonna be parallel into this for the amperage, not to go over, and even the wire size you're gonna use for that. And you have to, because since it's gonna be running on high voltage. And the other thing, where when and how, when to cut off power cutoff, or the higher end and the low end of it. And the other stuff is like trying to mention the other stuff for you. The max input voltage and efficiency of the device, nominal DC input voltage, the low start voltage, the low DC warning voltage, and the high DC coverage recovery voltage. So these are all the other stuff you have to know. And you can use AGM gel batteries on this device. So let's go back and start. I just trying to outline some of the things for you. I know a lot of you guys are high geared out there, high tech, but to be honest with you, there are few things sometimes we tend to forget or tend to pay attention to when we come to stuff like this, because we are overexcited. And I don't want excitement to take me off guard or get me off guard. Then I can't able to do what I'm supposed to do well with these devices here. They're kind of cool machines, you know. Yeah, you pay a lot of money for it. You got to make sure that you do the right thing. So the recommended battery cable and terminal use. So we can use for this 5 kVA, which is a 5 kilowatt. It takes a maximum amperage of 137 amps. You have to have a battery at least a minimum of about 200 amp hours. Okay, and the wire size can go from 2 gauge. You need a 2 gauge. What I would recommend, or what I will do if I have to do anything with this stuff, I want to make sure I beef up my wires. Some people has little tiny wires. Since they said it's a 48 volt, it doesn't mean because 48 volts I can use any flimsy wires. I can just use maybe number 12, 14, or whatever. I've seen some wires that really scare me when it comes to install. Don't try to be cheap on the wires at all, because that's how you build up resistance. You have a poor efficiency, and you're going to cause a risk of fire, endanger yourself, your family, and your asset and your investment. So I'm strictly into that. If you watch my videos, all my wires are oversized. I try to make sure I do the right thing. You know, we all not perfect, but try, okay? So it's not cheap when it comes to higher amperage at all. Some people thinking about, low high voltage, you tend to go with the smaller wires. Yes, it's small, but remember, if these ones are like 12 volts, you know, and the kind of wire you're going to be using. But we're running a 48 volt here, and a very, very high voltage. Okay, the minimum or nominal for battery bank is a 48 volt, but the input of this device is outrageous. It's 450 volt DC. This can really do some impact in your body, or maybe stop your heart. Okay, with the amperage, yeah, you're gonna get hurt. So the requirement is 2 gauge wire. Well, sometimes people I've seen like overseas, they don't tend to have some opportunity, because I'm here in the United States. They don't tend to have the bigger gauge wire as we do here. Right? Even if they do, it costs them a lot of money, because for the fact that they are using high voltage over there, which is a 230 volt. Some of the countries 230 volt AC, so their wires are smaller. So they don't tend to carry big wires like we do here in the United States with 120 volt, and we're running on a 12 volt system. Some of our a lot of stuff like RVs and all little portable gears that we have here, little gadgets like any of them over there as well. Even if they run a 12 volt, they're running at 230 volt out. So that saves them a lot of money on the wires, but we here have to pay the price for it. So I've seen people double number 6 wires, 2 of them, for them to if you open most of these Chinese inverters and all the other cheap inverters, portable ones, and quick as you go, just for the buck, bang for the buck, they end up having, on the positive or negative side, you see they kind of threaded the wires. You kind of wrap them, double them. That's what I meant. You double them, 2 wires on one terminal, the internal part of it, which is like maybe 6 gauge wire. Okay, they parallel them to become to give them just for the 2 gauge equivalency. But just for this machine, you need a 2 gauge number 2 wire that is required, which is a 38 millimeter square for overseas and other people that the metric system and other systems. And these are all the numbers. And or if you use the number 6, which is a 28, 2 of the 28, to give you the equivalency. The dimension, sorry, the dimension meter supposed to be 6.4. Okay, which is the length millimeter was about 39.2, and 33.2 if you use double of the number 6 AWG. So these are some of the stuff that you have to think about first before installing, or before go ahead and do whatever you want to do. You have to make sure you pay attention to all the machines you need, or the products you need, or the device you need, the wires, the fuses, the breakers, and all this kind of stuff. So you have to pay attention. Don't just get the device and get in a hurry and rush and trying to do everything in a hurry, because for doing things in hurry doesn't pay you. It doesn't do anything good to you. The thing is, you're gonna be the ones that are crying later, or you just throw investment down the drain. So be careful. And another second point I want to hit is the AC input and output connections there, and the wire that's required for this 5 kVA or the 5 kilowatt is number 8. Will you imagine, number 8 wire, which is required for even international, number 8 AWG. And you can turk that into 1.4 to 1.6 nm. So you guys know you have to use a torquing wrench. Sometimes you don't have it. You just go with approximation or estimate. You see, you were there. Okay. The other thing is for these ones, if you open them, you can tend to see, you're not going to see the American wire color, because each country, or a lot of countries over there, some of them because of the European Union, they have a certain code for the international voltage that they utilize. It's not like us in America. We have to use the white, the black, and the green, and the copper, solid copper for ground, at ground, you know, and we have the red and black as well. But here, for them, the ground is going to be yellow, okay, which is for us is green in America. Not in America, the America, let me just put it that way. And the live wire, which is lined for them, is brown, which is hot. The hot wire for us, which is alive, hot. There is brown for us, is black in America. And the neutral for them, which is blue. So the color coding, the coordination, the coding alone gets you confused if you open up this inverter. So if you want to do anything to this, make sure you have references and try to understand exactly what you're dealing with here, because it's some serious business you're dealing with here and costs a whole bunch of money. You don't want to destroy that. Okay. Okay. I think number 3. So like I mentioned, all the wires, and you have to understand when you open it and see some kind of different color, don't panic and make sure you stick the wire according to your country code. Put your wire where it should be. Okay, our hot cable, which is black for them, is blue, international, and which is sorry, the neutral is blue. Recap: the neutral is blue for them. For us, it's white, and the line, which is the we have here as hot, the positive charge, the hot wire, okay, is for them is brown, for us is black. Okay, it's a reverse. And the green, which is yellow for them, for us is green, which is the earth ground, is the ground wire. Okay, you have the earth ground itself. But let me go back to the other thing here. If you wire your solar panels, make sure for this device, the open circuit, the VOC, which is the sign for the VOC, that's an open circuit. Your solar array, the max PV array open circuit, which is the VOC, is supposed to be approximately or exactly at 450 volt DC. So if you pass this range, sometimes if you get too close to this range, your inverter won't just work. It won't recognize this because the voltage is too high. You already hit the high threshold, way beyond the specification onto this device. Okay, so your PV array maximum power point tracking, which is the MPPT voltage range, will start, the MPPT will start operating well on 120 volt DC to 450 volt DC. So your sweet spot supposed to be at 120 volt DC. So don't think about putting more 1 or 2 panels into the thing. You think it's just probably going to get what you're looking for. I'll advise you. I'm strongly putting this because I know some people about to do this. I know some people ask me questions. So I have about 3 panels or 6 panels. You think I can series parallel these panels? So if you have panels like that, it depends. If it's a 12 volt panels, I'll tell you 12 volt panels probably is going to be 21.5, 21 volt. Start to calculate that 6 of those panels. So let me say 20. Let's just take it 20. Okay, is 2, 4, 6, 8, 10, 12. That's 120 volts. 0.6 because that 0.1, the 21. So that will give you 126 volt. So you just made it, barely made it to the MPPT, which is 120 volt DC. But remember, this is an open circuit. When you put a load onto this thing, when they go into the inverter or the charge controller built into that thing, the voltage will drop. You will never see that 120 anymore. That will drag you almost probably approximately to 90 volt, 90 something volt, approximation. Okay, rough estimate. That will bring you down to that. So you're running at a very low voltage. Don't even think about, because they say these machines can run a battery less. Yeah, of course they're running battery less, but don't try to be complacent, like saying, oh, I have this thing, they can do voltage already made it to 100 or 120, that you think you can run something directly with batteryless mode into this thing. It's not gonna work. You're not gonna able. Okay, if you can do that, it might probably power some few light bulbs, but not heavy loads at all. It's not gonna work. So that's why the specification, they wanted you to go at a higher threshold, which is the open circuit, is 450 volt DC, because it's a 5 kilowatt each. So if you run the sweet spot of 120 volt to 450 volt DC, voila, you are good. You're talking about business here. So what I would recommend, if you have 12 volt panels, I'm not saying they're not good, but try to find a 24 volt panels, or maybe a 60 volt panels. They have panels with a high voltage and lower amps. That's probably the amps are just 4 point something or 6 amps. Go with the highest voltage panels, so you use only less panels with a high voltage and less amperage. All right, if you decide to get 200-watt solar panels, but this I would say I recommend like the over 300, anything with 300 or higher, 320 or higher. You can have 290 or whatever, is fine, but make sure you do the math. Calculate not the just the VMP, something like that, but make sure you check the VOC, the highest voltage on the panel on the back of it, the highest voltage. That's what you're looking at. I'll bring a panel here and show you exactly what I'm talking about. Okay, here is a clear reference of what I'm talking about. I'm going to try to keep this really steady. If you look at the maximum power at STC, the P max, see that? And go down, you see it said open circuit voltage, VOC. It says 22.7. This is just an illustration. It's not going to be part of that install. So I just want you to understand the terms that I'm using here. Some of you guys are familiar with it, and some people are just new, or some people, they see them, they don't even know what they really mean by that. But see, the optimum operational voltage, which is the VMP, that's what I was talking about, is at 18.5. So look, you put a 22.7 volt into that, and look what you end up going on when you already have a load, is at 18.5. That's what I'm trying to explain here. So I want you to understand exactly what I'm talking here, folks, because I don't want you to do a mistake. All right? So all right, I hope we get that clear. And now I'm going to be telling you your PV connection. The caution about this one old thing, make sure before you connect to a PV module, please install a separate DC DC circuit breaker. A DC is not AC circuit breaker. And make sure that you can able to cut off the power coming from your panels to enter in between, to enter the inverter. Okay, a DC circuit breaker between inverter and PV modules. So you have to have that. Don't just take one live wire or something coming directly from the, that's dangerous, because if you touch that 450 volt DC, that will hurt you. That really hurt you. If you touch those wires together, you get a big surge, a spark. Okay, and that's not good. It's gonna, you surge in your panels. What's gonna happen? You have diodes built on those panels back there. You're gonna cause some kind of problems. So make sure when you connect it to a disconnect, because if you have everything wired up, it's just a matter of you flipping the switch. The transition is going to be smoothly and swiftly. Everything just goes smooth. No interruption. Instead of trying to touch the wire, trying to go to live wire, trying to touch it, and the inverter started to come on and go off, come on and go off, come on. No, that's how you end up blowing up the inverter. Okay, so I want to tell you the typical amperage for this device. The amperage, if you series your panel and parallel them, if you want to do that, make sure if this thing is taking up to 4800 on panels, make sure you split it, divide it by 2, get exact panels that you're gonna able to split. Sometimes because of the panels you have, not gonna be able to give you exactly. Sometimes it's gonna go over. So make sure you have everything set up right. If it's a string, if you get a string of 9 or string of 8, this is just an illustration. On any panels like 3000 whatever, 300 watts panels or anything, make sure that you don't have to have a voltage discrepancy. If they're all 300 watt solar panels, 300 watt solar panels, 8 of them, 6 of them, whatever, get a string of that, and make sure the amps are not over 18 amps. This is what this machine required. 18 amps. Okay, 18 amps for this thing. You're looking at this as a 12 gauge wire. The wire size will be 12 gauge. Okay, but remember, it's better for you to have a beefy wire than have a flimsy wire, especially if you bury the wire. You cannot go back and just pull it out easily. So it's better, for my recommendation, or what I would do, I'll bury a huge wire, which in the future I want to change. I took this inverter, maybe I'm trying to do some other project, it's far away from you, and instead of digging all the conduit, just started putting another wire, all this. It's a waste of time and money. Do it once and for all and done. Seal that deal. The bigger the wire doesn't penalize you, the bigger the wire, it gives you safety, a peace of mind. Okay, and the flow of the electrons, or flow of the electricity, or the DC, or the AC, or whatever, you're not gonna have. You're trying to eliminate resistance, and it depends the length, the distance you have in this stuff too, because it has a huge factor, the distance from here and there, or where you taking it, and you're gonna be end up having a voltage drop all the way by the time you started going to the destination.